Welcome, class. I'm going to put the recording button up there. So we have a warm-up right here, and it says how many solutions does 2 times the quantity of x minus 4 equal 4 times the quantity 1/2 x plus 3/2. So you should see that both sides have 2. So we're going to go ahead and divide that 2 through, all right? So 2 divided by 2, that's going to wipe out. 4 divided by 2 is going to leave us with a 2. All right. So now we're left with x, the quantity x minus 4 is equal to 2 times the quantity 1/2 x plus 3. So let's go ahead and distribute that 2 through. X minus 4, 2 divided by 2, 2 plus 3. You should already start saying, hey, there's a problem here because of right here. But we'll see what I'm saying in a second. That gives us x minus 4 is equal to 2 plus 2 times 3, which gives us 6. What case are we in? 2. Yes, and it's going to be no solution as you see. And negative 4 plus 6 are not it. Negative 4 does not equal 6, so it's a no solution. So we're going to deal with literal equations and formulas over the next 2 days. So we're not going to have any word problems today, but there is going to be a handout. So just like the tips that I give you here should apply, and we'll have more word problems and bookwork tomorrow. So rearrange formulas equations, highlight the quantity of interest by isolating the variable using the same reasoning to solve equations. That's the main thing you want to look at. All right. So warm up, done. Vocab I'll have a look at. So start simple, go more complex, and last go from there. So review vocab, isolate. You know what that is. Simple interests, we'll be covering that in a little bit. Sorry about the birds screaming in the background. Variable, new vocab, will be formula, and literal equation. All right. So the gist of what's going on. This is something we've seen. 2x minus 1 is equal to 5. So let's go ahead and work through it and then replace the numbers with letters. Okay? So what we've done, we have added 1 to both sides. You get 2x plus is equal to 5x plus 1, which is simply 2x is equal to 6. Now we're going to divide both sides by 2. You get x equals 3. And as a check, 2 times 3 minus 1 is the same as 6 minus 1, which turns into 5 equals 5. Good to go. So what we're going to do is convert to a literal equation. That is an equation consisting only of letters. So there's no numbers, just letters. But we can still use the same math properties on these letters that we have used with numbers in the past. So let's go ahead and have a look at this as an example, the same one as an example. So we're going to swap out the numbers and letters and solve for x. So A is going to be 2, B is going to be 1, and C is going to be 5. So I'm going to bring over the equation and swap it over. So if you notice, all we did was take the 2, switch it over to A. Take this negative 1, switch it into B, or 1, switch it to B, still negative. 5, C. So notice how that 1, which turned to B, is still negative. That property still applies. So what we're going to do now is add B to both sides. If you've noticed, it's identical to adding that 1 to both sides, but we're pretending we don't know what that B is. Even though over here we saw what it was, we're pretending we don't know what that is right now, okay? So by adding a B to both sides, these B's, like the ones over here, cancel, and we're left with a C plus B. All right, so B's cancel, gone. We're left with C plus B. So we're still trying to get that X by itself. So now we have to take care of the A, which over here we saw it was a 2. As you see right here, we're exactly right here. 2x is equal to 5 plus 1. Ax is equal to C plus B. It's the same exact thing. So we're going to divide both sides by the A. All right. So here we go. Divide by that A. So you see what happens here is we're right here. The 2x divided by 2 is equal to 6 divided by 2. That's still technically 6, but we don't know what the letters are, so we're just going to leave it as is. And at least in this case, it's 6. So now we can just cancel off those a's, and we're left with x is equal to C plus B divided by A. So notice that all we did was apply the same properties. We're able to subtract we're able to add, we're able to multiply, we're able to divide. So this is a very easy example of the gist of what's going on under the hood, what we're doing. We started with an example that we already know what to do with, and then just went through the same example without the numbers, but with the letters. All right, so we would circle this and say, hey, that's our answer. We're good to go. So let's go ahead and start simple. Often it'll ask you, when it gives you a bunch of letters like this, it might give you some numbers, like this 3, but not a lot of numbers. And we're asked to solve for b, which right now is negative. So what I would always recommend, if it's asking you to solve for a particular letter, like in the handout, look for the letter you're after and work your way back. Since we're asking for b, we're looking at that we have this negative b. So we want to isolate b and get b by itself. Notice there's several ways. We can either leave the b on one side or move the b. So we're going to solve this 2 ways. So first, let's leave the b on the one side, okay? So when we go ahead and do that, realize we're going to have to then subtract that 3c from both sides. All right? So when we do that, with c's cancel, 3c plus minus 3c, it's going to be 0c. That's going to be gone. Same principles apply. So now we're going to be left with x minus 3c is equal to negative b. But now we need to take that and multiply by or divide by negative 1. In this case, we're going to divide. So when we divide by that negative 1, what's really going on is we're dividing each and every term by that negative 1. Remember that rule? Even amount of negative signs turn positive, odd number turn negative. So let's just go through and eliminate the even ones. All right? So as you see, those are even, that's turning positive. Those are even, that's turning positive. So what are we left with? X divided by negative 1 turns into negative x plus 3c equals b. So it's just a way to look at it. You could have also done the same thing with a multiply and look for the equal amount of negative signs and just eliminate them, and then we'll call it good. So as you see here, this is one way to go about it to get to the answer negative x plus 3c is equal to b. And this was done by simply leaving the b alone. So now we're going to try to move the b instead, okay? I'm going to hold off here just for a second, and then we're going to continue. But you should be able to look at this, pause it, and take notes if need be, all right? So let's continue. And this time we know what the answer is, so I'm going to grab this, chuck it over here from the last side. This is the answer we're expecting to get from the last side. Negative x plus 3c is equal to b. But this time we're going to move the b. So instead of leaving the b, we're going to move it. So we're going to add b to both sides, okay? So let's go ahead and add b to both sides. X plus b is equal to negative b plus b. As you see, the b's are canceled on the right side at this point. So now what we're going to do now is going to go ahead and focus on the x. The x needs to move now because we want the b by itself. So we're going to rewrite it one time and then move it up and move the x. So we're going to subtract the x from both sides. So when we do that, the x's are gone, and we're left with b is equal to 3c minus x. It's the same answer, just swapped. For instance, if we look down here, 1 minus 2 is going to get us negative 1. Negative 2 plus 1 also is going to get us negative 1. This is a very similar case. So negative 2 minus 1 is the answer from the other side, and the 1 right here is the 1 minus 2. So as long as you keep the negative sign with whatever numbers you have, everything remains the same. The x is negative in both of them, the 3c is positive in both of them, we're good to go. Okay? So we got the same answer, it was just swapped. So you see there's multiple ways to get to the answer you're after. You don't have to go down one pigeonhole. Alright? Let's continue. Well, this one's a little bit more complex, but we're going to kind of have a look at it from a mathematical side of things to understand what's going on here. Because look what we're trying to get to. We are trying to get that a. As you see, we have 1a here and 1a here. So we're multiplying a by 2 different quantities, and that might be a little bit harder to figure out what we need to do, okay? We could just divide everything, but first, we could divide everything by a, and then I'll put it over there. That's another way to go, but there's also this whole factor. And factoring is important for other math classes, so it might be a good idea to understand. So let's partially simplify the following. Partially meaning we're not going to get all the way to the end, okay? Just to understand what's going on. So we have that 2/3 because so just aside, you could divide everything by a, but that would still cause some problems because then you would have to figure out how to multiply by a and things like multiply again by a, try to do it differently. So dividing by a would lead you down a very long rabbit hole. So because the a would have to be on top. Anyways, so let's just go and partially simplify this. So what we're going to do is distribute that 2. So 2 times 3. Then we're going to distribute the 2 again. 2 times that -5. All right? So we've done this plenty of times in this class already, so we can see what's going on here. Now, let's let a equal 2. So everywhere you see it 2, we're going to replace an a. So you saw how we kind of distributed. So we can undo or go backwards what we did via factoring. Okay? So if we're looking at that, we have that a, pulled it out, 3 minus 5. We are able to go backwards by pulling out the a to get that 3 minus 5. We could take out the 2, take out the 2. So going backwards got us to this. All right? So it's pulling out the a, return this to this state. So let's go ahead and have a look at our example. All right? So now that we have that kind of understanding, let's go and give it a shot. So if you need a bit, everything to go back and just pause it and have a look at for your notes again. So notice we're still after this a. So what we're going to do is we know we're going to have the b on the one side, the left-hand side, not touching right now. But we want to pull the a out from that 7ak. When we do that, all we're going to be left with is that 7 and that k. So pulling the a out leaves us with that 7 and that k. Now we're pulling the a out also from that -2l. So notice that we don't have an a squared. We're just taking those, extracting them, factoring out that a, and we're leaving ourselves with that quantity 7k minus 2l. So you see, if we divide by a, we could have had p divided by a, but then it would have been a little bit harder to go. But this one makes it very easy. So you see that all this is multiplication. So what you could do is divide both sides by that 7kl. And when you divide by the 7k2l, those are gone. And you're left with b divided by 7k minus 2l is equal to a, or a is equal to b, but divided by the quantity 7k minus 2l. Both ways makes are valid answers, but it just depends which way you kind of like it. Personally, I prefer this one, but both are acceptable answers. All right? So you see how we work through that. Yeah, so it's a little bit more complex. We had to understand what we were doing with the factoring, how to pull out that a. That's why we went over a general example of how to pull it out with distributing. All right? Let's move on. This is the last example, and we want to solve for b. So always identify what you're after. You don't have to circle or anything, but just say, this is what I'm after. How do I work backwards? So right now, you see the problem is we're dividing by that 3c. We're also subtracting this amount from that 2a, and we're multiplying by that 2. So we need to take care of the multiplication of -2, the addition of this 2a, and the division of this. So opposite division is multiplication. So let's start off by multiplying by that 3c, all right? So when we do that, we have to distribute 3c, just like we did earlier. 3c spread around, and we can cancel. So we're left with 2a minus 2b is equal to 3c. So you see there's a couple different ways we can go. We can either leave the b or move the b. So let's just go ahead and move the b, so we don't have to worry about dividing by a negative, because that makes inequalities a little bit of a fun issue. So let's just try to make it positive is what I would recommend. So we're going to move the b over. That way we can cancel there. We have 2a is equal to 3hck plus 2b. Now, well, again, we have addition and multiplication to take care of. Let's take care of the addition by subtracting the 3ck from both sides. That cancels over there, leaving us with 2b is equal to 2a minus 3ck. The last thing we need to take care of is multiplication. Opposite multiplication, division. So we're going to divide both sides by that 2. And when we do that, the 2's cancel, and we're left 2a minus 3ck divided by 2 is simply equal to d. So it's a little bit of a challenge, but you have the tools to take care of it. So give this a pause, give this a try, or it's a checkpoint. You have the tools to be able to solve this. So pause it. You're trying to solve for a for this one, and your a is down here. Okay? So, welcome back. If you go ahead and look at it, what we need to do is get the a by itself. So we're going to, again, realize that there's 2 a's down below, so we're going to extract it. So this is kind of like the problem you were going to have if we divide by a. So notice that we had to extract the a, and then we're going to multiply both sides by the a, leaving us with canceling on one side, c divided by 2b plus 1 is equal to d a. Now we just divide both sides by 1 d, or multiply by 1 over d. Either side multiply 1 over d. That cancels the d on one side, leaving us with c is equal to 2b plus 1. Now if we distribute that d, notice what we get. We get the same exact thing we have here, but instead of a's, we have d's. So we look through and try to figure out which one that would be. 3. So, well, not 3. 3 has a C down below. Silly me. It's 1. All right. So, classwork today. We'll have some Pearson work tomorrow, and I'll hopefully be back then. Have a wonderful day.